students, in our previous class, we defined derivative of function of two variables, so more than one function of more than one variable. Then some definition of derivative of for single variable we discussed for just for revision, and some examples for partial derivatives we did, I think. So today we will discuss this some examples on this. So partial derivative, what you need to know these things. So actually this one, say if f is f of say xy is equal to say x plus say 5x square y. So to do these things, if you are to take partial derivative with respect to x, then one thing you have to remember, this you have to consider this as function of x only. So this is 5x square y. So this y you ignore this, totally ignore these things. So totally ignore it, is just like this. You need not do anything on this y. So so this is as your function of single variable, only x and 5x square, only x and x square you have to do. So derivative for x, so ddx of x, so it is ddx of x plus 5y, you take it outside, it doesn't have any function for this, you keep it here. Then you do ddx of x square, this one, only function of x you keep it, this 5y you take it outside, and now you can do it. So ddx of x is 1 plus 5y, it is as it is, and then ddx of x square is twice x. So this is your process to find partial derivative. In a similar way, suppose you have to find ddx of ddy, say. So this is function of two variables. So what you can do, partial derivative with respect to y of this same function. So it is x plus 5x square y. So with respect to y you have to do. So this it is with respect to y we are doing. So it doesn't have anything with this. So because you can say this del y of 1 you can write, because there is no y. So the constant 1 is there, and this into x is take outside, and after this you take out this 5x square, and this is del y of y. So this one, because it is constant, so this is 0, so it is 0, x into 0 is 0, plus del y of this is 1, and it is 5x square into 1. So ultimately this your derivative is, partial derivative is 5x. So very simple, we have to do like this. Suppose you are to find derivative of, suppose you are to find, say sometimes say they suppose you are to do del z of is say x plus 5x square y, but no z is here no z, so you can do this, and that is why you don't need to do this. Actually this no meaning, it doesn't have any meaning, because this is not function of z. So this type of things you have to ignore. You can't have del del z for this because z is not here. So this is partial derivative. And for this problem, first problem, fxy is equal to x cube y minus thrice x plus y square plus 1. So f of x means we actually we denote this del del x, we denote it as del x, we denote it as fx. This is equivalent as fx, where it is del x of f function. So del x of, so this one, this is f of xy, and also we can write it as, this also we can write it as is equal to f of x. This you can write it as f of y, f suffix is y. So this fy is del y of x plus 5x square y, partial derivative of f with respect to y. So fx, so here for example number 1, so fx is, so function is x cube y minus thrice x plus y square plus 1. So x cube y, so x cube y is this one, so we are separating all this, x cube y, then minus thrice x plus y square plus 1, etc. Then 3x square y. So x with respect to x we are doing, that is why y you leave, and x cube derivative is 3x square. So this y, it will be unchanged here. So it is 3x square into y. Then minus thrice x, it is simple, it is minus 3, and y square, because just like this thing, just like this one, that because there is no z, so it is meaningless, or you may write directly this value is 0. You don't have any meaning for this actually. So if you have to take this, you will have the value 0. So similar is this one. So here there is no x, so y only, so this value is 0. Or this also you can see del y of x, because it is you can explain like this, x is taken outside, and del y of 1 is within, because it is constant, so the value is 0. So like this. So this is your 3x square minus thrice x plus 0 plus 0. So ultimately your answer is 3x square y minus 3. So this is fx. And in a similar way, this fy is partial derivative of this with respect to y. And partial derivative of this with respect to y, and this is also in this case you are to take this x cube outside, then partial derivative of y with respect partial derivative this y, so del y of y, so value is 1, then this here is no y, that is why value is 0. This is y square we will have twice y, and this value is 0. So your answer is x cube plus twice y. So you see fx is 3 into x square y minus 1, and here fy is x cube plus twice y. Then fxx, so this is second order partial derivative, fxx. So fx, so first you are doing partial derivative this fx, and this fx, just like that in case of single variable, what did you have in case of single variable? What did you have? Suppose your y is equal to say sine square x, or sine of twice x, say. Then your dy dx is, or you may write y1 this dy dx, it is 2 cos of twice x. And when you say y2 means what? it is d dx of again this value. So d dx of this y1. So in a similar case, this is fx, this is fx, and fxx is, so this fx function, and then you take derivative of this, partial derivative of this with respect to x. So del del x of fx, and that is denoted by fxx. Similarly, fxy, so del del y, first you take fx, then with respect to y you take partial derivative. So this is del del y. So this is second order partial derivative. If we write fyx, then you take first fy and then you with respect to x, like that. So these are same functions. This is del del x of x cube minus del del x 2xy square, etc., etc. So very simple ones. So like this, and this one you say the square root is here. So square root is here. Actually, you have to know the formula for derivatives. You should be thorough for this. So this you see, z is this. So del z del x. So del z del x, del del x of, so you do this one, x square plus y square minus 4. So this one. Then this thing that how did you do it? It is d dx of this. So keep this y square as some constant value. So it is like root over x square minus 4 plus some constant. So it is 1 by chain rule you apply. So it is 1 by 2 root over x square plus y square minus 4 into del del x of this one, x square plus y square minus 4. And partial derivative of this is, it is twice x, this will be all 0. This one. Similarly, del del y, it is same value we will have. It is y by root over x square plus y square minus 4. Then del to z del y square. So first you take del z del y, and then you again with respect to y of this function. So you need to know all this formula. This is again it is fraction. So for fraction you have some formula, u by v. So denominator square is v square, and Indian numerator will be du dx into v minus u into dv dx, like that. So we are just applying the formula, only symbol is different. So very simple things are there. So you just go on practicing these things. So simple, all are simple things, very simple. This del z del y. So if we want to discuss, what can you say this one? Z is equal to xy. Number one, what you can have? Number one, you have to find del z del x. So number one, del del x of xy minus 4x square plus e to the power x. So del del x is with respect to x, so 1 is coming and y is remaining same, minus 4x square, it is minus 8x, and plus e to the power x is e to the power x. So this is del del x. And what about del del y? Del del y of xy minus 4x square plus e to the power x, and this will be what? This is with respect to y. So with respect to y it is 1, so x will come, x del del y of y is 1, and others it doesn't, it will not come because it is function of x square, so value is 0. This function of x, it is 0, so this is value, so only x will come here. So this is del del y of, so del z del y is x, and del z del x is y minus 8x plus e to the power x. So this is the way to find this. Or number 8 you can find. Number 8, how will you do it? Number 8. So del del x of 3 by root over xy. So this is equal to, or you may write 2 by root over y, you can take it out. 2 by root over y. Then del del y of del del x of x to the power minus half, you can say. Then it will be easy. Minus half minus half. So it is your 2 by root over y. Then it is minus half, then minus half minus 1. So it is minus half into x to the power minus 3 by 2. So this is your answer. So this is your z del x. If you simplify, 2 and 2 will go. So you will have, after computation, you will have minus sign is there. Then 1 by x, I think it is x into root over xy, because power of x is 3 by 2 and power of y is half here. So you can check it, maybe somewhere mistaken also. You check it here. So these are a way you have to say this thing. So this is del z del to z del xy. You do partial derivative of partial derivative 2 times you do. First you find del z del x, then again with respect to x. This is first with respect to y, then again with respect to y, then this is first with respect to y, then with respect to x, first with respect to x, with respect to y, etc., etc. So this thing, when you will do on your own, then you can understand all these things. Thank you.